questions from you to me? The standalone does not shut the turbine. It only cuts the power to the dispenser. And that's an option that they can have. Which if I was a UST owner, I would prefer that. Because that it's only gonna shut me that dispenser, not the whole station. Now pop quiz. What types of overflow prevention devices are available? Or how many at least? There's 4 options, but the devices are 3. We have the bulb float that is in the bend valve. We have the ATG, or audio and visual alarm, and we have the flapper valve. By what date were all facilities required to have UDCs? You know that one. 2003, yes. And now I'm gonna give this to Cecilia. And after this, I think we're gonna head to lunch.
So as you guys know, today's mostly a training day, so I think we're not tied to Coupa lunch times. Everyone does lunch on their own time, so we've put breaks in and lunchtime in to, to accommodate the flow of the presentation. So just so you know, I don't think there's a formal lunch today. Also, before I get started, just want to address a couple questions some people had. Some of you may be getting ready to take your ICC exam, and some of the questions were, a good way to study. And although this presentation is not specific for the ICC test, one thing I'd like to point out that you can take from this presentation is that we mentioned dates a lot, installation dates, dates for certain requirements, and those are the types of things that you want to stand out. Like I said, this presentation will be available online after the Coupa conference. But the best recommendation is to know where you can find the information you need within the regs or within the law. That's going to be your most helpful thing when you go in to take the test. You don't want to memorize where everything is, but you want to know where to find the information. Yes? Of the actual exam or tests or no, I don't think we can do that. We have a bank of questions that have been developed for training purposes, and I'm sure some overlap, but don't actually sit down with. I'm going to go back up here. We don't necessarily develop a bank of questions based on input from inspectors. I don't know how legit that would be, but if you ever need training questions, you can always contact us, because we have put together training questions, but they're not necessarily pulled exactly from previous tests. And I think they're different anyway, as within a sitting and then within the different years, they get changed. But anyway, so like I said, this is not a specific ICC presentation, but it is beginning, and a lot of this stuff will actually be on the exam, but my 2 recommendations would be pay attention to the dates we talk about, and also just get real familiar with the locations of topics such as monitoring requirements, installation, and that type of thing. That'll help you. Just knowing that will help you 50% without even doing any sort of studying. So with that being said, I'm going to talk about tank monitoring requirements. This is a lengthy, not as interesting topic within this presentation, but I'll try and keep you guys energized and awake and know that lunch is coming soon. And then I've broken it up to talk about tank monitoring now, and then we're going to go into detail on pipe monitoring afterwards, so as not to get confused and also to, keep you guys awake. All right, like I mentioned before, the date becomes very important, not just for ICC, but also for knowing what type of system you're dealing with. If you know the date of installation, it's going to tell you a lot. So I've broken it down based on installation dates, how I'm going to discuss them. first designation is a single wall tank. It's the only single wall designation, actually. So these are obviously going to be tanks installed on or before January 1st, 1984. So of course, after 84, or January 1st, 84, you're going to need double wall product piping only. But I also throw in the designation, but before 2003, the July 1st date. Okay, because once you hit July 1st, 2003, you're going to have different requirements. And of course, if you remember, that date is also going to trigger different components are now defined as pipe, such as the vent lines, vapor recovery piping, and fill pipes. So you notice number 3 here, it's double wall piping, tanks, on or after July 1st, 2003, but before July 1st, 2004. So here you have a 1 year, a 12-month period where you have different regulations from the previous year, and you're going to have different regulations after this year. So just keep in mind there's this one 12-month section, and then since July 1st, 2004, you're going to have, of course, double wall piping, but it's going to have the continuous monitoring system by vacuum pressure or hydrostatic testing or monitoring, and we'll get into detail on that. 2 and 3, just the dates. So, yes, and I'll go into detail. Yeah, 2, 3, and 4, it's all double wall piping, but they all have different requirements based on their install date. So, and we'll touch on each of these as we go through. Okay, so just to stay focused and not get too confused, until I say otherwise, we're going to be talking about single wall tanks exclusively, and then we'll discuss double wall tanks. Okay, so a single wall tank is considered existing. If you remember, existing tanks are those that were installed pre-84, January 1st, of course, and this reference is in Health and Safety Code. And here's a summary of the different single wall tank monitoring methods. And similar to what Zoraida said, you're always going to have your popular methods and some that you just never see. So I'm going to focus on number 1, 2, and 3. And 4, 5, and 6 are very uncommon, and I'm not going to spend too much time on those. But if anyone has some input on those items, you can, certainly jump in. So I will go into detail on each of these methods. Okay, the first method is going to be statistical inventory reconciliation, also known as SIR. Not as common, but it's still an option. And the criteria is that it must be able to detect a leak of 0.2 gallons per hour, and it's also conducted in conjunction with a biennial tank integrity test, which is every 2 years. And SIR is going to analyze different components. It's going to analyze your inventory, your delivery, so your dispensing of your fuel leaving the system. And this data is collected over a period of time. And using this data, it's going to determine if the tank system is leaking. So I'll go into some additional detail. Inventory. So each operating day, the product level must be measured. And you can use this. You can do this electronically using a monitoring system or a tank stick. And that tank stick should not be in the flapper valve, when you're not using it. So delivery, you want to make sure all deliveries are measured and recorded, so you know how much is coming in. And of course, dispensing, you want to know how much is leaving your system. So you're going to do daily meter readings to record this, to keep track. So these are the data points, and they need to be collected for a 1-month period, and this data is then sent to your SIR vendor. And at this point, the SIR vendor will take computer software, input this information, and in turn will conduct a statistical analysis of the data. And this will help determine if the UST system may be leaking. Once the vendor provides the results, the owner's going to look at the results. And of course, you have an inconclusive or fail that's showing some sort of issue or some sort of problem. So the owner is required to notify the local agency and submit a copy of that inconclusive or failed report to us within 10 days. And at that point, you want to figure out what's going on. Is there an issue? Is there an issue with the information you collected? You know, you want to make sure your tank looks right. You want to do an inspection of the components that you can see. So if you don't find any obvious errors, what do you do? Okay, so next step, you want to at least calibrate your dispenser. So then you know at least the information that you're providing to the SIR vendor is as accurate as possible. So of course, if you still have an inconclusive or fail, then you want to conduct a piping tightness test, or if necessary, a tank tightness test within 15 calendar days of receiving the report. Okay, so that was SAR. Not very common. We did have a few locations in San Diego that were using this method. I'm not sure if they are anymore. But another slightly more popular option is the ATG method. And it's a monthly in-tank test, and it detects also a 0.2 gallon per hour leak. You have two modes. You have inventory mode, and you have leak test mode. And you're going to have an ATG console that is maintaining this information, and it's also can be equipped with external sensors and light leak detectors. So typical V-root type scenario where you have your ATG connected and it's used as overfill, but it's also using as leak detection for a single wall tank. Like all UST components, it's required, an ATG probe is required to be maintained annually. So I'm going to go into detail. I talked about leak detect mode, and then inventory mode is exactly that. It's letting you know the inventory of the tank at all times. But leak detect mode, you're going to require to obtain the level and temperature readings, and they're taken automatically every 1 to 2 seconds, and then averaged every 30 to 60 seconds. The level and temperature readings are sent to a microprocessor, and it's going to convert these readings to temperature compensated volume measurements. So it's basically allowing you to analyze the data and determine if you're having any unusual changes in your volume. So your threshold, it's going to be expressed in gallons per hour, and it's going to be compared to, like I said, a threshold. So you want to be, it's going to compare it to determine if you have a fail, inconclusive, or a pass. So this all gets very wordy, but basically if the absolute value of the temperature compensated volume change exceeds the threshold, then a leak is suspected. So like with any other testing, you always have that threshold. You go above it, it's a problem. You stay under it, you're good to go. If it stays below that threshold, then it's considered a pass. Okay, so the way, and I'll get to the next method, also uses the ATG probe, and I know there's a little confusion with specifically which method, because they're both using the ATG, they're both for single wall tanks, but the other one I'm going to discuss is a continuous method, and sometimes it's difficult to tell which method you're using, but one way to tell is that the printout for this method, the ATG method, it's going to have a lot more data, and all this data has to be on the printout for it to be a legitimate test. So you're going to look for the date, time, tank ID, product depth, water depth, volume, product temperature, duration of test, and then after 95, the calculated leak rate should be on there. Okay? And then the monthly test shall take place after product delivery or when the tank is filled to within 10% of its highest operating level during the previous month. So it's fairly complicated, and it requires levels of fuel. When you're in leak test mode, you're not operating, so that's a disadvantage for this method. And we'll talk about the next one in just a minute, but just to give you a visual, here's what an automatic tank gauge access port would look like. This one here is in a direct bury access area, However, most of them are found in fill sumps. Also, just to reiterate, the same diagram I showed you is, right, this is the ATG probe, and this is where you're going to find it within the tank. So sometimes it's nice to come back to these diagrams. So, depending on how new you are to UST systems, this will allow you to actually visualize and know how they're actually being used in the field. Okay, so I'm going to talk about continuous in-tank leak detection, also known as CITLD. And this also uses the ATG probe. However, it's a continuous collection system of information. That's how I would describe it. And that's how I would differ it from the previous method, is that it's continuously collecting product level and temperature data. And this is also be done by the console, the monitor. It's going to discard data from unstable times and low product levels. And once it's collected adequate data, a leak test will be performed, also at a leak rate of 0.2 gallons per hour, which, as you can see, is a common theme here with the single-wall tanks. And it can be programmed, since you are using an electronic monitor system, it can be programmed to print out the results monthly, daily, or weekly. But at minimum, you want to have a monthly passing test. So when you're out doing your inspections, you often find that tank owners will have a daily printout, which is super fun to go through when you visit the site every 12 months. Depending on how organized they are, they might have a shoebox of these reports. So, like I said, at minimum, you want to have a monthly passing test. 4, 5, and 6, we specifically get into manual tank gauging for small tanks, groundwater monitoring, and vadose zone monitoring. And I think I referenced that incorrectly, but for number 5, I said see also LG 137-1, but that LG letter, I believe, references manual tank gauging for the small tank. So I apologize for that. And also, if you've noticed, we've referenced several of these LG number letters. These are local guidance documents put out by State Water Board, and I list the reference for them at the end of the presentation. But these are great guidelines for local CUPAs. It kind of, some of the more confusing parts of regulation, they might provide additional detail or frequently asked questions. And most of the LG letters that we do reference in the presentation, I did bring copies of, so if anyone wants to review any of them, just let me know. But here are the references for these other items, and we chose not to go into detail because we actually, right now in San Diego, we don't have any of these options, and I think they're probably not common at all. So, okay, pop quiz. Single wall tank installed on or before January 1st, 84 is considered. That's right, existing. So what are some examples of single wall tank monitoring methods? SAR, ATG. Yep, the continuous ATG. Good, good. You guys are listening good. And of course, groundwater monitoring, vadose zone, and the manual tank gauge. Okay. Now a sip of water. All right, now that we're, oh, yes. Uh-huh. Yeah, so the question is, if they have continuous monitoring, which was option number 3, do we still require them to test the floats? Is that right? The answer to that is depends. If they still need to do that as part of the overfill test, the functionality, that's how they test that. But if they have flapper valves, I don't know that we necessarily would. But I can't think of an exact example. But most of the time they're coming out anyway because of overfill. at least in San Diego, that is definitely a primary overfill method, is the 90% using the ATG. And then oftentimes corporations, even though depending on their monitoring plan, and they are using a flapper valve, oftentimes those ATG probes will get pulled and certified by the testing companies regardless of the CUPA recommendations. And as much as, I talked about the graph showing we have federal, California, CUPA, I would say the next level of stringency might even be the business owner. Oftentimes, the business owner will do things that are not required by the CUPA, but it's part of their business practice just to keep on top of everything. So, does that answer your question? Okay. Any other questions before we move on to double wall tanks? No? Okay. Oh, let me go back here. Okay, so we keep mentioning the term existing. So where do we go from there? We have our new tanks, and that terminology is given to tanks installed after January 1st, 1984. So although those tanks don't sound so new anymore, that's still a common designation if you're referencing Title 23. So like I said, these tanks were installed after January 1st, 1984, and at this point, double wall piping was required. At this point, and I'll go into details about the post-2003 tanks in just a minute, but at this point, only the product piping needed secondary containment. So your vent lines, your vapor recovery, and your fill pipes do not need secondary containment. So this is strictly referencing your product piping. So with double wall tanks, you only have one option. You don't have 6 options. You're doing continuous interstitial monitoring. That's it. However, you have 2 options. You have 2 types of interstitial monitoring of your choosing. Before we get there, let me tell you a little bit about interstitial space and that type of monitoring. It means the space between the primary and secondary containment systems. Okay? And if you're doing continuous interstitial monitoring, you have the ability of being alerted when there's a leak from your primary tank. You're going to alert the operator, and both methods of double wall interstitial monitoring for tanks will come through an electronic monitoring console, so you'll know right away via an audible visual alarm. So in order for the sensors to work, they need to be placed or firmly secured at the low point within the secondary containment, because that's always where the fuel is going to go first, and you want to find your leak at your earliest opportunity. And like the ATG, the leak detection equipment shall be maintained annually. And here's an example of common leak detection monitors and consoles. Here we have the Veeder-Root, which we all see so frequently. A little less frequently, but still out there and still being installed in new systems. You have the Incon, and then here's a Boudreaux system that's often seen at Shell or Tesoro sites. Have any of you guys seen these outside of San Diego County? Yeah? All right, so we have 2 types of tanks, 2 types of double wall tanks. We're first going to talk about steel tanks, and then we're going to talk about fiberglass tanks. So let's get moving with steel. If you can tell by this picture, your interstitial monitor for a steel tank is going to be in this interstitial space will drop the sensor all the way to the bottom of the tank, a straight drop tube, okay? And you'll know why this is different than fiberglass, but this is an example right here on the bottom of a typical steel annular space sensor. This happens to be a Veeder-Root 420 model Bell sensor. And that's going to have a straight drop all the way down to the bottom of that secondary of the tank. So as with any component or underground tank item, you always want to check for proper placement of the sensor. You want to check for any swelling or cracking of these sensors, which can happen. We've had these sensors swell up and crack to a point where they look like a tulip flower, and you can't get them out of the the riser. And you always want to make sure the sensor is on the bottom of the tank. And there's two ways you can do that with a steel tank interstitial sensor. One, it's nice you have steel on steel, so you can hear the little ding of the sensor on the bottom of the tank. That's the less technical method. The more technical method is you can actually measure the drop tube. You're going to want to pull that sensor anyway because you're not doing a functionality test. But you can measure from the bottom of the sensor to the point where it connects at the top and make sure that the length on that cable is long enough. And here we have fiberglass tanks. This is an example. As you get more familiar with UST systems, you're going to be able to look into a sump, and if you didn't have any other information from the site owner, you're going to be able to know what type of tank you're dealing with just by some of the visual characteristics. And one of the common visual characteristics of a fiberglass tank is this ribbing, and you won't find this on steel tanks. You're going to have more of a smooth surface for the steel tanks. Here's another picture example of how you would have interstitial monitoring for fiberglass tanks. And these sensors are called wraparound sensors. I believe the model number, this is an example, whoops. This is an example of another Vidroot brand sensor. And it's a wraparound sensor. And in this little part of the casing is a float switch. And that portion of that wraparound mesh is going to be what you want to find at the bottom of the tank right there. So these get a little more complicated because you actually have to work that sensor into the bottom, and it's less easy to know if it's on the bottom. But hopefully the technician has some idea of what's normal, what's the normal amount of time to get to the bottom. A way you can tell it's at the bottom or close to the bottom is that if you have a turbine shut off, your turbines would kick back on once the sensor got to the bottom of the tank, because that means the float is going to be sitting where it should. So that's going to allow the turbines to work, okay? When that sensor is going down the side of the tank, it's going to react as if it's in alarm, so it's not going to have the turbines running. So, you know, it's hard to tell if it's exactly at the bottom of the tank, but that's one way. And like with anything else, you want to look for cables that are, you know, are in good shape. You want to watch out for cables that have been spliced. Sometimes these can be a tangled mess, which you'll see in the next picture I show you. And oftentimes these sensors get lost down at the bottom, and then they need to get pulled out somehow. So you often see fish tape that's hooked on to bring them back around. But so here's an example of that. This is not what you want to see. So I think if you got to a site like this, you would recommend some sort of retrofit or a new sensor install. And then you're hoping to find something a little bit more clean and organized. And this way, it gives you a little more confidence that the sensor is going to end up where it should be. Okay, so like I mentioned, there are two methods for interstitial monitoring for double wall tanks. The first one being a dry interstice, and then the second option is hydrostatic monitoring. So you're going to have some sort of fluid in that interstice, whether it be propylene glycol or brine. Those are the common types of hydrostatic fluid. So for obvious reasons, you know, let's bring it back around to corrosion protection, but you're not going to find this in steel tanks for obvious reasons. So this is strictly for fiberglass tanks. So here's an example of how it might work. The first picture up top, it shows you a normal condition, and I'll show you some field pictures as well that can show you some of the details of this type of system. But you notice here you have, anytime you have a fiberglass tank that's going to have the hydrostatic monitoring, you're going to have a reservoir here at the top that's a part of this secondary tank. And this reservoir is where your liquid level sensor is going to sit. And the reason the reservoir is there, it helps with the normal fluctuations you might find It helps maintain a little bit more of a stable environment for that sensor. So anyway, the reservoir liquid will be stable if both the inner and outer tanks are tight. And even if they are tight, you're still going to have slight variation, but the sensors are made for that. They're going to allow for that. And if you notice here that in this picture, the green is going to be your interstitial fluid, while the yellow is going to be your product pipe. And on the bottom here is a picture of how it might look if you had an inner wall breach. So you have your product piping in the primary tank, the yellow. Sorry, this pointer's not fabulous. Here we go. Anyway, the yellow is the primary product, and that's going to be in the primary tank. And once again, the green is going to be your interstitial fluid. And this is showing an example of a breach in the inner wall. So if you have a breach in that inner wall, you're going to have that interstice fluid flowing into that primary tank, in which turn the fluid will drop and the sensor will go into alarm because it senses a loss of reservoir liquid. Okay, so it's going to drain, and there's no petroleum product that escapes from the primary, and it's not going to pollute the site, but it still indicates there's a breach in the primary, and obviously that needs to get repaired. So here's another example of an outer wall breach and where that fluid might go. So, and it also gives you two different scenarios if you have high groundwater versus low groundwater, because that high groundwater is going to add some head pressure as well. So if you have a groundwater level that doesn't totally encapsulate the tank, you're going to have the fluid drains into the ground, which also causes the reservoir to drain, and that's going to cause the sensor to go off. However, with a higher groundwater and the higher pressure, you're going to be forcing that external groundwater into the secondary. But that's still going to affect the reservoir. It's still going to give it an increase. Okay, so it's still disrupting the equilibrium within the reservoir, which is going to give you the alarm. And here's just a field example of what that reservoir looks like. This is a picture taken from a new install, and obviously fiberglass tanks, and you can see the two reservoirs on each of those two tanks. And here's examples of the monitoring sensors. The sensor on the left is a dual float sensor, and the one on the right is a single float. It's my understanding that the dual float sensor will indicate on the monitor that whether you have a high liquid level or low liquid level, so it's going to let you know, it's going to give you a little bit more information than the single float. Okay, the single float will go into alarm if you have a loss or a gain, but it just won't register on the monitoring system the exact problem. Either one you need to investigate, and either type of sensor you should be investigating. Okay, so as I mentioned, we had your double wall tanks that were between 84 and 2003. I'm going to talk about the tanks that were installed between 2003 and 2004. So this is a very specific group of tanks just in this 12-month period. I'm going to let you know how they're a little bit different from tanks previous to 2003, but then they're also going to be very different from the tanks that were installed post-July 1st, 2004. Okay, so the first point, nothing changes. These USTs must also be capable of detecting the entry of a hazardous substance stored in the primary containment to the secondary containment. How do you do that? Monitoring system. So that hasn't changed. You're still having to monitor that secondary part of the system. However, this is where things start to change. So for these systems, they are required to be product tight. And within this definition, product tight means impervious to the liquid and the vapor of the substance that's contained, so as to prevent seepage of the substance from the containment into the backfill. So if you notice, from a field perspective, how do you know if you're dealing with a pre-2003 tank versus post? One way is when you lift up the sump lid, you're going to notice that post-2003 tanks have concrete on the outer wall of the tank top of the sump, whereas with pre-2003, you're going to actually see the backfill. But don't forget, these have to be vapor tight. So if you have that backfill that's open to that sump area, you're gonna have the ability to have that vapor seep into the backfill. So that's one of the visuals that might indicate you have a post-2003 tank. And unfortunately, I don't have a picture of that, but you'd probably know it if you saw it. And we had a couple of situations where around that time, we had a few tank installs where it was a post-2003 tank, and they did not have that concrete seal, and they had to go back and retrofit due to the installation date of that system. Okay, additionally, secondary components must be installed to prevent water intrusion into the system by precipitation, infiltration, or surface runoff. So you want to have your tight penetrations. You don't want to have groundwater coming in. You need to take measures to not allow the precipitation to come into those sumps. And don't forget, this is a list of 5 items that are changes from the pre-2003 tanks. And then I've mentioned throughout the presentation several times where this 2003 date is a big date with definition of piping. So within these post-2003 tanks, the vent pipe, vapor recovery pipe, and fill pipes beneath the surface of the ground now are considered pipe per definition, okay? So that means they're subject to secondary containment and every other monitoring requirement as the product piping was between 87 and 2003. Okay, so piping exemptions in 25-281.5 are no longer applicable. Okay, well, yeah. Well, we'll get to that. So his question was, if you have a vent pipe installed this year, do they need to have monitoring with sensors? If it was installed this year, we're going to address post-2004. Yes, but if you had a tank installed in this time frame, this 12-month time frame, you're going to need to have the vent piping secondarily contained, monitored. They're going to need secondary containment testing and everything else that was required with product piping. But it's a funny question because if you ask if it was installed today, it's going to have additional requirements. And we'll get to that. So the last item that was needed for these types of tanks was that the UST needed to be tested after installation, but before it was placed into use, okay? So you have 3 test methods. We've only ever seen one in San Diego, and that's number 1, which is enhanced leak detection, also called ELD. And we'll go into greater detail specifically about ELD later in the presentation with Zoraida. Or you can have an inert gas pressure test that would be certified by a third party, or a test method that would be equivalent to ELD and would also need approval by State Water Board. Okay? So, the Big Daddy monitoring systems for USTs installed on or after July 1st, 2004, also known as VPH. We're not going to talk about those right now. So, you guys are going to have to wait for that excitement. I chose to do everything post-2004 to talk about at the same time, talk about tanks and piping at the same time. It'll be a little bit more comprehensive and easier to follow. So we'll have a whole separate section on post-2004 tanks and piping. So a quick pop quiz, and then we'll let you guys out for lunch. Can SIR, Statistical Inventory Reconciliation, be performed on a double-wall tank? No? Yes? No? Why not? I can hear that answer. It's not allowed. So only continuous interstitial monitoring is allowed. So no SIR for double-wall tanks. What 2 types of interstitial monitoring can be used on double-wall tanks? Yep, hydrostatic and dry. Can you do hydrostatic monitoring on a steel tank? Why not? Corrosion. You don't want that big gaping hole in your tank. So dry or hydrostatic, that's right. If a UST system was installed on December 30th, 2003, would the vent line be single-walled or double-walled? Double-walled, that's right. Because post-July 1st, 2003, vent line was defined now as pipe, which means it needs to have all the same requirements as the product piping post 84 tanks. Okay, so would this same vent line and this same system also need to be product tight? Yes, product tight for both vapor and liquid. Okay.